Welcome to the Explainer. We pass by immense feats of engineering every single day, and we usually don't even think about the microscopic battles happening right inside the materials holding them all together. Well, today we are exploring the super metals that literally keep our world from falling apart. Let's get right into it. So, I want you to imagine something with me for a second. Picture a massive offshore oil rig just standing out there in the middle of a raging ocean. Think about the sheer, unrelenting, extreme forces of nature that are constantly trying to tear that structure apart, right? You've got crushing weight, fierce vibrations, and this constant, highly corrosive salt spray. Or think about the inside of a chemical processing plant, dealing with highly volatile, highly acidic materials 24/7. What actually keeps these colossal structures from dissolving, cracking, or just straight up collapsing into the sea? Well, believe it or not, it comes down to the tiniest components, the fasteners. Okay, let's dive into this. Here is our roadmap for today. First, we'll look at the Industrial Fastener Challenge. Then we'll break down the chemical recipe, followed by mechanical superpowers explained. After that, we'll pit Super Duplex against standard steel. And finally, we'll meet the master builders over at Aanuraj. Starting with Section 1, the Industrial Fastener Challenge. It's essentially the ultimate battle against corrosion and stress. Now, to defeat these extreme environmental villains, engineers actually rely on a very specific hero. It's called Super Duplex 32750, or sometimes you'll hear it classified as UNSS 32750. Now, to be clear, this is definitely not your everyday hardware store metal. It is a high-performance stainless steel alloy, and it is meticulously engineered for extreme strength and exceptional corrosion resistance in the absolute harshest environments on the planet. Basically, when standard metals fail, this is the heavy hitter that steps in. Let's look at the real-world battlegrounds where these specific fasteners are deployed. We are talking about marine and offshore structures that are permanently submerged in seawater. Deep water oil and gas rigs, where insane pressure and toxic gases are just part of a normal Tuesday. We also see them heavily used in chemical processing plants, handling super reactive agents, and massive desalination facilities, separating salt from water. In these kinds of brutal environments, ordinary steel? It would start to pit, rust, and ultimately snap in a matter of months, honestly, maybe even weeks. Moving on to Section 2, the chemical recipe. Let's see how they cook up the ultimate metal. You can kind of think of a metallurgist like a master chef, combining highly specific elements to create something entirely new. The fundamental makeup of Super Duplex 32750 starts with a really high chromium content, usually sitting between 24 and 26%. You take that and combine it with 6 to 8% nickel and a pretty heavy dose of molybdenum, right around 3 to 5%. The rest of the balance is made up of iron and a few trace elements. This specific high alloy triad, chromium, nickel, and moly, is exactly what provides that crucial baseline defense against harsh chlorides and acids. But here's the kicker. The real secret spice here is a tiny, tiny addition of nitrogen. We are literally talking about just 0.24 to 0.32% of the total volume. It's practically a dusting. Yet, this fraction of a percent fundamentally alters the atomic structure. It massively boosts both the mechanical strength and the localized pitting resistance of the alloy. It is a tiny but absolutely mighty ingredient that literally makes the super in Super Duplex possible. All right, on to Section 3, mechanical superpowers explained. Let's look at this physics in action. So, all those precise chemical numbers we just talked about, they translate into some serious mechanical superpowers. When engineers build something like an oil rig, they need to know exactly how much force a single bolt can take. Here, we're looking at a yield strength sitting at an impressive minimum of 550 megapascals. That means it can take an incredible amount of stress before it permanently bends or deforms. And that 15% elongation, that means it actually has the toughness to stretch a bit under extreme loads rather than just instantly shattering, all while maintaining a really rigid, durable maximum hardness of 32 HRC. But the real standout figure here is 795. That is the minimum tensile strength in megapascals. If you're not familiar, tensile strength is essentially the maximum amount of stretching or pulling force a material can withstand before it completely breaks or tears apart. And guys, 795 megapascals is an absolutely massive number. When you are threading a heavy hex nut onto a stud for a high-pressure valve sitting on the dark ocean floor, you need a fastener that will hold that joint together no matter how violently the ocean tries to rip it apart. That 795 guarantee, that's what makes sure it holds. This brings us to Section 4,
Super duplex versus standard steel. It's the ultimate industrial rivalry.
You know, we hear a lot about standard austenitic stainless steel, specifically grade 316. It's everywhere, and honestly, it does have good general corrosion resistance. But if you put 316 into a highly concentrated chloride environment, say a desalination plant, it really starts to struggle. Super Duplex 32750, on the other hand, offers exceptional pitting resistance in those exact same chlorides. Plus, and this is brilliantly illustrating the difference, to get high structural strength with standard 316, you have to use a lot of it, which creates incredibly heavy structures. Super Duplex gives engineers a vastly superior strength-to-weight ratio. You get lighter, way more efficient designs without sacrificing an ounce of safety. So to summarize this whole rivalry, here is exactly why Super Duplex just completely dominates the heavy industry sector over standard stainless. First, it has exceptional pitting and crevice corrosion resistance in seawater. Second, as we just saw, it provides a much better strength-to-weight ratio. And, crucially, it has outstanding fatigue and stress corrosion cracking resistance. Think about it. When a platform is constantly vibrating from heavy machinery 24/7, standard steel can eventually succumb to fatigue and crack. Super Duplex just absorbs that stress and maintains its structural integrity. It's really a no-brainer.
And finally, Section 5, the master builders, Aanuraj. Who actually makes the best fasteners?
Because when you are manufacturing the exact fasteners that prevent massive offshore oil spills or chemical plant disasters, pedigree really matters. This level of engineering expertise doesn't just happen overnight. Aanuraj Fasteners Pvt, which is based in Vasai, India, was originally founded way back in 1965 as Rajesh Engineering Works. Decades of scaling, learning, and perfecting their craft led to their evolution into Aanuraj Fasteners in 2018. And they are continuing to supply some of the most critical global industries today and well into the future. So, the crucial point here is the secret behind that pedigree. Over 50 years of dedicated experience. Aanuraj brings half a century of institutional knowledge specifically to the manufacturing of these high-tensile, super-alloy threaded fasteners. That kind of longevity, it's an absolute guarantee of reliability in an industry where failure is simply not an option. That history is literally baked into every single hex bolt and stud they produce. But why exactly are they considered the absolute best? Well, it really comes down to a strict, non-negotiable process. Step 1, they utilize state-of-the-art CNC and hot forging machinery to physically shape these incredibly tough alloys. Step 2 involves strict adherence to international manufacturing norms. We're talking DIN, ISAs, and ASTM specifications, like ASTM A276 and A479. They aren't just guessing here. They are following the global blueprint to the letter. And Step 3, they run rigorous third-party testing to verify every single batch before it ever ships out. All of this intense dedication is backed up by their formal ISO 9001-2015 certification. But it's not just a run-of-the-mill certification. It is provided by TUV-SUD South Asia Pvt. Ltd. If you're in the world of industrial manufacturing, you know that an audit by TUV-SUD is pretty much the ultimate gold star. It proves their quality management system isn't just slick internal marketing. It is undeniably independently audited as world-class. We've seen how Super Duplex 32750 holds our current world together, constantly fighting off the harshest elements on Earth, thanks to master manufacturers like Aanuraj. But as we look to tomorrow, to things like deep space exploration, next-generation geothermal energy, and maybe even underwater habitats, the demands on our infrastructure are only going to grow more extreme. So I want to leave you with this final provocative thought. Knowing the incredible mechanical superpowers of these alloys, where else could we use these supermetals to build the future? Thank you so much for joining me for this explainer. Keep asking questions, and I will see you next time.